Hi everyone. Welcome back to our SQL training series. In this video, we're going to solve question 14, how to find the most recent 3 orders for each customer. We're working with 2 tables, customers and orders. The customers table contains customer number, which is the primary key, first and last name, postal code and phone. The orders table includes customer number, order date, requested quantity. There is no primary key in the orders table, and a single customer may have multiple records for the same order, for example, multiple line items or products within the same order number on the same date. Our goal is to find the 3 most recent order dates for each customer. For each of those dates, return customer number, order date, total requested quantity for that date, first name and last name of the customer. The final result should be sorted by customer number in ascending order and order date in descending order. Let's look at a quick example. Suppose customer 2342594 has 5 records. The most recent 3 order dates are November 1st, September 27th, and January 31st of 2023. On September 27th, the customer had 2 records with quantities 24 and 9. These should be summed to 33. Please note that the example is to show the logic only, and the input table data may be different from the actual data in the database. The expected output is the following. Now let's begin with the first SQL solution. Method 1. Subquery plus window functions. In this query, we use a subquery or CTE-like derived table A. We call it a CTE-like derived table because it can be changed as common table expression with similar performance. Let's break it down. We use a subquery like a temporary table to sum the requested quantity per customer per order date using a window function. Sum over partition by is used to calculate the total quantity a customer ordered on a given date, summing all records on that day. Rank the order dates using dense_rank, so we can filter only the top 3 per customer. Dense rank over partition by is used to assign a rank to each order date per customer. Then we join with the customers table. Filters to the top 3 most recent order dates per customer using RK equal or less than 3. Since the subquery does not collapse multiple rows for the same customer order date, use distinct to remove possible duplicate rows. Orders the result by customer number and order date. Execute the query and we can get 484 rows. Now let's see method 2. Use common table expressions for a more structured and optimized solution. Here's what's happening. We use first common table expression CTE to groups by customer and order date, aggregates quantity per day, uses max order number to show a representative order number. In the second common table expression CTE1, applies row number to assign a unique rank to each order date per customer. Filters out the top 3 most recent using where RN equal or less than 3. The final select joins with the customers table. Displays clean, non-duplicated results sorted as required. Execute the query and we can get the same results. Let's see the performance and efficiency. The first query is shorter and easier to read, just 1 subquery or 1 common table expression, but this query is slightly less efficient due to distinct and sum over on all rows. The second query is slightly longer with 2 common table expressions, but it is more efficient due to group by, which means fewer rows processed in ranking. To recap, if you're looking for a quick, simple query and you're confident about the data structure, for example, minimal duplication, then the first method is sufficient. But if you want to ensure clean, accurate output with better control and performance, especially on large datasets, the second method using CTEs is the better choice. That's it for question 14. Thanks for watching. If you found this video helpful, please like, comment, subscribe, and share this channel. Thank you.